Good day everyone and welcome to another video. Today I'm going to introduce you to another large language model, and this one is Claude.ai. So this is similar to ChatGPT in the when you prompt it, it will give you outputs. This one, however, I'm introducing it to you. You can review it here, claude.ai. So that's Claude.ai. It's run by a company called Anthropic. It's a competitor to OpenAI, ChatGPT. But this one, in my opinion, is much better with data and more specifically with code. So I've preloaded already some test data. What I'm going to prompt Claude to do, this is theoretical data. It's not from any specific project. I've just randomly generated this scenario. Basically, what we're going to do is we're going to ask Claude to do a number of things around cost data and predictability of cost. So let's assume, for example, that we have some real good data that is from a project. And we want to utilize that data to see whether there are any consistent patterns, any good regression that we can use to predict costs around other scenarios. So the test data that I have here, what I've done is I've generated three different scenarios around substations. So three different types of KVA as a rating, and then five sets of theoretical competitors' rates. So, in other words, if we were in a real-time environment, we might have, bid rates, specialist contractor rates for these different categories of KVA. I'm going to ask Claude to generate regression and confirm the regression model. Is it good? And then I'm going to ask it to predict a KVA outside of the three parameters and see what it comes up with in terms of cost. So what I'm going to do now is give the prompt. So I'm going to run through this before we run all of this so you can see what I'm actually going to ask Claude to do. So I'm going to say, or I have said, create a construction cost model using regression analysis for the attached data to predict a cost of a 1500 kVA substation. Now, within this test data, as I mentioned, there's only three types of KVA. So I'm going to tell it again because I want Claude to understand what's in the data so that there's no misunderstanding from the AI's perspective. So there's three different data types of KVA from 5 different competitive sources, thus a total of 15 data points. I'm telling it to look for 15 data points. If I don't tell it that, it may make an error. So I'm telling it specifically that I've got 3 KVA types and 5 competitive quotes or rates for those 3 types. So 3 by 5 is 15 data points. Confirm the model formula. I need the regression formula to be able to predict, and the R squared together with the confidence levels and whether the model predicts well. I want to see, we'll know the R squared, we'll know automatically whether it's a good model or not, but I want the AI to confirm that. I want you to also create a visualization of this regression model to better understand the relationship between KVA rating and cost. Finally, run a Monte Carlo simulation over 100,000 runs to predict the ranges and confidence levels based on these 15 data points, together with central tendencies, confidence intervals, distribution of predictions, and key insights. So basically what I'm asking it to do is run a Monte Carlo simulation over 100,000 iterations to understand the data based on those simulations and see whether we have a good model, a bad model, or something in between. And the visualizations just help us to understand where those data points fall as well. Now, I haven't tested this, so let's see what we get. When we get the results, we may have to prompt Claude more to get what we want, but let's see what we get. Right, so it's thinking about it. And there you go. It's telling me what it's going to do, and it's analyzing it. It's using code. It's generating that by itself to generate a result. Now it's confirming that it can see the data structure, so it's performing the regression and calculating the necessary statistics. Now, where it's saying React, this is basically a JavaScript. I could have prompted it to give it in Python, then we can run it in Google Colab, but that's absolutely fine. So, what you'll see here is it's delivered us the model formula. So, a number by the KVA, which in this case we want 1500, plus another number. So, it's predicted a cost for a 1500 KVA of 940,000 based on the data points of a 200, 500, and a 1000 KVA, 5 data points. Now, the R-squared value is 0.237, which is really not very good. The 99% confidence interval would show that the predicted cost is 349 to 1.5. So that's a very broad range, and it's because the R-squared is not very high. Now, the reason the R-squared is very high is that, sorry, not very high, is because it's analyzed the statistics and there's not necessarily a dependency between the KVA and the rates. Let's go down. One thing I don't think it's done is run the Monte Carlo, but let's see. So it's just confirming the formula that we've seen there for KVA. The predicted cost is 940. The 95 confidence interval, so we're 90% confident, 95% confident, sorry, that it's 349. So we're probably going to have to do further work to analyze this a little bit more to see whether the 940 is really a good indicator or predictability. So yeah, it's confirming it's a relatively weak fit, which at 2.237 we kind of already know that. So the large confidence interval suggests high variability in the predictions. The standard error is 217, so not particularly flash. So the Monte Carlo simulations, okay, it did run it. It ran it over 100,000. So the fifth lower bound, conservative, median, higher, upper bound, key insights, 23%, suggesting that a low quarter of can be explained. So yeah, this is not a particularly good result, but it's good from the perspective that AI has literally within seconds confirmed that this data is not very good for our ability to predict. So that saved us a lot of time. Imagine if we were doing this, looking at all the data and calculating all this ourselves and trying to come to that conclusion. We've come to that conclusion in seconds, and we've saved ourselves a lot of time in the process. So it's going to give us a rough estimate for 100, that high variability that you should use this as a rough, consider additional factors, account for a wider, possibly connect more data points. So it's also giving you scenarios of what to do. So I hope this gives you a broad understanding of Claude and how it can be used and how we can basically take the results from situations like this and be able to develop something either more meaningfully, or we can, immediately know whether we have something that is going to be predictive or not. And in this case, if this was a real-time scenario for me, I would be diving deeper into understanding the cost drivers of the substations, looking more particularly around getting into additional factors that would bring that regression analysis up higher to a 0.7, 0.8, ideally 0.9, maybe looking for more data points from friends, colleagues, that type of thing to get that regression higher. But also, really, when you look at cost drivers and break down more components, it may just be more than one factor, in which case we can then use an AI LLM to start working with a multilinear regression model. So we don't necessarily have one factor that contributes to the cost driver. We might have two, three, four, or even more. So in this case, it's prompting really more analysis for us to think about. But again, the AI has helped us enormously by shortening the time to draw that conclusion very, very quickly. And the iterations of the Monte Carlo has also kind of confirmed that we have really not very high confidence in this model, even though we run it over 100,000 iterations. So we need to go deeper, and we need to look at the cost drivers a lot more, and we need to find possibly more data points. Again, I've described how we would do that, or we would engage with a supply chain and start to understand by phone calls with them what drives the cost and how we can get a better model. So I hope that helps you understand what it can do. And it's more about the thinking process. It's more about helping us to digest information and not just assume that it's correct. We've tested it. In this case, it's wrong. And the data set was driven specifically to show and highlight that everything is not hunky-dory, and what we can do to then further think around the scenario of next steps and making ourselves better in terms of predictability. So I'll see you in the next one. Hope you enjoyed it. See you later.